I'm Manish Kumar. I have been working with Oracle, in specific with MySQL, for the last almost 4.5 years. And I work on the replication module of MySQL. In specific, the new project that I'm working on is MySQL Group Replication, which is a new solution from MySQL. Just to start with, this is the safe harbor statement. Maybe we can just have a look at it. Let's get started. So this is the agenda that I have today to talk about group replication. Starting with the theory, how things work, how to use it, and conclusion. I'll try to keep it short so that you can have a couple of questions to be taken at the end of the presentation. So how many of you have used MySQL replication? Okay, yeah, we have used. So replication is a way to provide read scalability. We can have a very intensive master server, and we can replicate the data onto the slave so that the performance of the server doesn't go down if multiple reads are happening at the same time. So traditionally, MySQL replication has been following the primary backup approach, wherein we write the data on the master. We write it into a log file, which is the binary log file. We ship the data to the slave, where it is applied onto the slave, and this process is asynchronous in nature. So we write on the master, we commit back to the client saying that the transaction is applied, and in the background we send the data to the slave. As you can see, if we have more reads, we just scale this out by adding multiple slaves to the master, and we can then connect the read clients to those slaves instead of connecting it to the master, which is only used for write purposes. Another use of replication has been in provisioning. So suppose server A, which is the master in this case, is replicating to slave B and C, and more often than not servers go down, and in that case we'll have to provision the new master. In this case, A crashes and we promote B as the new master, and C starts replicating from B. So all the writes now start going on to the server B after master A has crashed. So, in both these examples that I had shown, the replication from the master to the slave is asynchronous. As I mentioned, we write on the master and replicate to the slave in the background. With MySQL group replication, what we are planning to give is all the servers will be master. There will be no slave on this. So clients can actually connect to all the servers and start writing to the database simultaneously, and the entire handling of conflicts will be taken care by the group replication setup itself. So here in this case, we have a group of 5 servers, and clients are connected to 3 members in this group. All the clients can access the same database and keep on or modifying the data in those databases simultaneously. So just a moment. So what group replication is? It's a multi-master update everywhere replication plugin that we have, wherein we are supporting automatic distributed recovery so that new members can join in the group without any handling to be done from the user. Simultaneously, we are providing conflict detection so that if 2 servers are being updated simultaneously on a particular row in the table, we can detect that conflict and roll back one of them. And we provide group membership, which is a way to establish how the members are present in the group. So, and what are the use cases of it? Excuse me. There is no need to handle failovers in this case, because all the members in the group are at the same state. So in case a member crashes, all we need to do is direct the client to any of the remaining servers in the group. We provide fault tolerance. We provide update everywhere setups, wherein if there are 5 nodes connected and you execute a transaction on one of the node, we are sure that the data will be there on all the other nodes simultaneously. And we provide automatic group reconfiguration. We can add and remove members in the group seamlessly by running very simple commands of which I'll talk about later in the slides. So what are the use cases that we are trying to address? The first one is elastic replication. So in regular master-slave replication, the traditional asynchronous replication, in order to add a member, we had a lot of steps which would actually make it an active member in the group, active member replicating from the master. With group replication, this process of adding members and removing members is very seamless. You can just add a member and be sure that it will replicate from one of the servers in the group and be at the same state where all the members are currently. As Ricky talked about sharding, so with group replication we can have a very highly available shards, wherein so sharding is a way to provide write scalability. In case we have 100 rows, we can just split it in groups of 4 of 20, say index 1 to 25 in each group, and which is called shard in this case. And all the writes to indexes 1 to 25 will go on to one shard, and all the writes to index 26 to 50 will go to the another shard. This provides write scalability, and we can have a group replication set up for each shard. So in that way, the shard that we have is highly available. In case a node crashes, we are sure to have a backup of the data that we have. And of course, it is an alternative to master-slave replication. In case we are very much concerned about the consistency of the data, then we can have, instead of a master-slave setup, we can have a group setup wherein we can have the same number of servers connected as a part of a group. So this is the theory behind it. So group replication is based on the database state machine approach, which is which says that if you start off with 5 members from one state and we feed the same set of transaction to them, the end state reached by all the servers will be the same. And the backbone of it is the group communication, which is based on atomic broadcast. So each time a transaction executes on one of the server, it is atomically sent to all the servers which are a part of a group, so that all of them have the same set of data in the same order. I'll talk about the group communication system that we are supporting as of today. Okay. So group replication is based on deferred update replication, wherein what we do is when we execute a transaction on one of the server, we delay the commit till the point it is certified on all the members in the group. So if I execute a transaction on one of the servers in the group, before the commit it is actually sent to all the other members in the group, and only once it is certified it is committed. So we defer the commit at a later point after certification. And one of the key concept here is view synchrony, which is the last point here, which ensures that, so let me talk about what view is. So view is the membership of the group at any instant. So at any instant, if a group has say 5 members, we say that the view ID is 1. As soon as a member leaves or joins this group, we need to change the view, and view is an atomically increasing number, it never goes down. So the whole idea is that a message which is delivered in one view needs to be delivered before any other view is installed, and that forms the backbone of the entire group replication. I'll explain this to you in a later slide with a small picture that I have. Okay, so how things work. Okay, so as you can see, since group replication is very tightly coupled with the server, we can leverage on all the benefits and all the positive points that are existing in the server as of today. So a very simple way to start is we create a user because group replication adds members to the group using asynchronous replication in the background, and for that we need a user. The second step would be to just start off with the correct configuration. So right now, group replication works only with GT, which is very much needed for handling of transactions inside the group. We don't support checksum as of today, so checksum has to be off. We support only row-based replication, and the info repository has to be in the table format for a group replication. So that's the basic setup that we need to do for just configuring group replication. So this will start the first server. From now on, if we want to add a new server in the group, all we need to do is to create a replication, to just set the two variables that are there in the top. Do we have a pointer here? Is the red one?
Yes.
Okay. So these are the two variables that we need to set when we add a new member, which is the recovery user and the recovery password. So in group replication, it's very easy to add members in the group and make sure that the data is already there on that new member by setting these two credentials, which will be used to connect to one of the donor being one of the online member in the group at any instant. And for the communication part, you just need to set these four variables. The first one being the group name, which identifies a particular group. Currently we support only a valid UUID as a group name. UUID is a 36 word length character set that we have, which is used to identify the group name, and it's also used to log the transactions that are there in the group. Then we have these two server parameters, which is the local address and the peer address, which is used for the group communication purpose only. There is no use of it in group replication as such. It's for the configuring the communication toolkit that we have. Local address is the address that we use for the local machine, and peer addresses is actually a comma separated list of all the member, the IP and the port of all the members that will be a part of this group.
So it means if we have 3 servers.
Yes.
So on the server 1, it means we only list the server 2 and the server 3.
Yes. So on server 1, you set the local address of server 1,
okay,
and the peer addresses of server 1, 2, 3 also, but you can omit 1 if you don't want. On server 2, it will be the other way around. It will be local address will be the server 2 address, and on the peer address it will be server 1 and 3 addresses. And this variable is only used for the first member, which is used to bootstrap the group. Again, this is only for the communication engine. It's not, there is no use of it once the group application is running. This is only for starting the communication engine that we have.
Okay, so what if you have 3, then, because you said it's only on the
First member?
right?
Yes.
What if the first member dies?
First member dies. Now, so one booted the group. So this is basically the one which will boot the group.
Okay.
So first member booted the group, second member joined, third member joined. Now first goes down. If you want to add a fourth member, it is going to add seamlessly. Once the entire group goes down, and then you start a group again, then you need to set this member on the first member. So once the group is running and the first member which booted the group goes down, you can very well add a new member in that case. But once the entire group goes down and then you want to add a new member, you need to set it as 1 on the first member. That will boot the group again. So how things work here? So in this case, in this setup, we have a 5-member group which is online. Online being that it is serving transactions concurrently from multiple clients. And now we have this new member, which is a single node, single MySQL server, which wants to be added as a member of this particular group. So all it has to do is set those particular variables that we talked about in the previous slide and just execute a simple command, which is start group replication. What this will do is it will start the recovery of this node so that it is it becomes an active member of this group. It starts getting data from one of the donor, which is an online member of the group.
And this is automatic?
Yeah, this is automatic. No one has to, all we have to do is just execute that particular command, start group replication. However, I would like to talk about this particular hint. In case you want to add a new member to a very long running group, you are bound to have a large amount of data that will be recovered. So one of the better way would be to just provision the server using MySQL backup or any other backup tool, and then add it as a member of this group. That will be much faster. Otherwise, you are guaranteed even then to get the data using the normal distributed recovery procedure that we have. And once, so till the time it is getting the data from the members in the group, it will be in the recovering stage. As soon as it is in sync with, as soon as it has all the data in the data that is already there in the group, it changes the state to online, and we now have a 6 members group in this particular setup.
So if we use MySQL backup, then how does it know, oh, this is where I should continue from?
So MySQL backup has ways to add data using GTD. So what you need to do is you first back the data and you set the GTD parameters, GTD purge and GTD executed. Once you do that, it will identify how the data we are in sync, and then the recovery will end and change the state to online. And now we have a 6-member group. Similarly, if you want to remove a member of the group, say for some handling the server, all we need to do is just execute a stop group replication on the particular member that we need to disconnect. And so in this case, suppose the view ID was 4 when these 5 members were online. We executed stop group replication, so this will automatically inform all the other members in the group that one member has left, and the view ID will change to 5 because the membership has changed. Similarly, once we do all the setting up in the removed server, we just add the same server using start group replication. The view ID changes again, and the member changes from recovering to online. So in this way, adding and removing members in the group is a very simple process. You can do it very easily with just simple commands.
The view ID will keep on increasing.
Yeah, the view ID will keep on increasing. So this is a simple way how transactions are executed. In this case, you can see that these are 3 clients connected to 3 different members in the group. We have this client executing an update on table T1 where set A is equal to 3 where A is equal to 1, and we are updating T1 here on a different member which is setting A is equal to 4 where A is equal to 2. So ideally these 2 transactions are non-conflicting. These are updating 2 different rows, so they can be executed parallelly, and simultaneously it will work on both the members. In the second example that is shown here, we are setting A is equal to 3 where A is equal to 1 on table T1 on one client. We are executing A is equal to 2 where A is equal to 1 on the same table from another client. So locally it will pass till the commit point on both the members. At the commit point, as I discussed in the previous slide, that it is synchronized with the group. During that time, the first committer wins. So in this case, let's assume this happens first. So this will be committing and this has to roll back.
Does it mean we have to disable the auto commit?
No, we don't need to disable auto commit. Auto commit for, so we don't handle DDLs as of now. This conflict detection is only for DMLs as of today. So DDLs has to be handled separately. This can be done for DMLs as of today. Any questions on this slide?
If you want to configure as a multi-master, it's an additional configuration, right?
No, there is no additional configuration.
By default, it will be a multi-master.
No, for setting up a multi-master, as I talked about, all you need to do is set this configuration and start group replication.
So all becomes master.
All becomes master. As and when you add members, it will become an active member of this group, and this group will be having a multi-master setup. So now the benefits of group replication compared to some other solutions that we have is group replication is very tightly coupled with the server, so you can leverage on all the benefits that exist as on server. So it is fully compliant with GTD. So it will be, so all the transactions are logged with the group name, which I mentioned in the previous slide is a valid UUID. So the group transaction will be logged as group name :1. If transaction Y in second transaction will be logged as group name comma 2 on the other different clients, on the different servers. The benefits of performance schema, we have instrumented all the parameters that are of importance for group application, and we have performance schema tables for each one of them, so that we can see the flow of the transaction that we are executing inside in the group. So this particular table, application connection status, talks about gives the status information about that particular node. This is the group member statistics, which will talk about how the transactions are being processed. Say transactions in queue, transactions which are used for conflict detection, transactions which were positively certified, transactions which were negatively certified. These details will be there in this particular table. Then we have this particular table, which is on all the online members of this group, and it is a multi-row table. It will give the details of the different members of the particular group. So only for online members and recovering members, these values will be there for this row, for this table. For offline members, it will just be a single row table. Any doubts in these two slides? Conclusion. Group replication is an easy solution to read scalability for cloud solution, which adds and removes members quite dynamically. It's highly integrated with the server core with a very well-defined API. GT-based support, row-based application, performance schema are just few to talk about. So we can leverage on all the benefits that exist of MySQL server, which is 5.7 server. All the benefits of 5.7 are there in group application as well. It is self-healing, no administrative control is needed. Ideally, there is no need of anyone to do any provisioning. You can just start it by setting up the server parameters and start group application. Everything will work fine for you. Provides fault tolerance, multi-master update everywhere, so your application don't need to search for the most active member of the group. You can connect to any member and be rest assured that your data is there on the members. It's still on labs, so it's still not production ready, but we are actively developing it, and we can use it with other solutions that we have in the labs, like MySQL router. This is the timeline that we have had for group application and the lab releases that we have had. We have had 7 lab releases till date in a year and a half. This was the 6th one was special because till lab release 0.5.0 we were supporting CoroSync for the group communication toolkit, but since 0.6 we are supporting a new communication solution, which is XCOM. The benefit of it being it is platform independent now. CoroSync had a limitation of Linux and Oracle Enterprise Linux and Linux, so that was the limitation. It was not multi-platform. It is not platform independent. XCOM is. There were few issues with Windows, which was fixed in the next lab release, which was 0.7. So ideally, on all servers in which you can run MySQL, you can run MySQL group application without any problem. The communication engine is shipped as a part of the solution that we have, and it works on all the platforms. So it has been an active development for group application over the years, for the year and a half that I have been involved with. What you can do is probably try it out from labs.mysql.com. We have the latest 0.7 release available there. We have wonderful blogs from the engineers, some of them written by me as well, on mysqlhighavailability.com, which talks about the ways to set it up, to use it in a very simple way, and we would love that you break it and report bugs to us on bugs.mysql so that we can improve on it in the next release. That's all. Not sure if you have any questions.
And do you mind going back to
the sure,
slide? Some more. Like before. Some more. Yeah, this one. When you, what's the difference between the insert X and insert Y?
So if you have two transactions, both the transactions have to be identified individually. So these are on two different nodes. So insert Y is logged with GT group name :1. So if you, the GTID format of MySQL is UUID : a sequence number.
Yeah.
So let's suppose we have, since we support GTID, so insert X is logged with group name : and group name is used to as a UUID part of the transactions.
Okay.
So we log the first transaction with group name : 1 and the second one with group name : 2.
Okay. So it means we can do our own load balancing, or
Yes, you can.
okay. But there's no mechanism like in which there's something listening to the request and it will load.
Okay, for that I would like you to mention about this slide. You can use it in combination with MySQL router. MySQL server, you need to use tools on top of MySQL server to actually do the load balancing part. So MySQL router, probably I forgot to mention, you can use MySQL Fabric as well, because Fabric nodes are smart enough to decide where to write and what to write. So MySQL router is one thing which you can use with MySQL Group Replication for load balancing part. MySQL Fabric is for write scalability, if you want to go ahead with that. Any more questions?
Can you go to the slide with the first commuter group?
This one?
So you said that if, both the transactions make changes to the same tuple,
Yes. On two
Only
different
one.
servers, yeah?
but it's the same. But
Yes, same
record,
row, yes, same row.
But only one of them is committed. Is it?
This one.
Okay.
In this one you're talking about?
Yeah.
Yes. So what happens is, if you are setting, so in this particular example, I'm updating table T1 by setting A is equal to 3, where A is equal to 1 on node 1, and we update table T1 on by setting A is equal to 2, where A is equal to 1 on node 2. In this particular case, when the transaction will be broadcasted to all the members in the group, the transaction will always be ordered. But in this particular case I am talking about, it will be ordered this particular transaction followed by this particular transaction. So once this is committed, during certification process, once this is committed, the second execution, which will update the same row, which is identified using the primary key, we will know that we are having a stale data compared to what when we executed the transaction. So when we started the transaction, we had a particular state which was changed by the first transaction, and the second time when it is updating the same row, because the identifier doesn't change, we see that we are working on the stale data, and in that is how certification works. Once that is known, we just roll back the particular transaction on all the members in the group. That is never committed. So the first one commits, second one is rolled back.
Okay.
And it will never happen that the ordering will be different on different members. It will always be T1, T2 on all the members of the group.
And certification is exactly what you certify which commit.
So certification is based on, so we identify each row using the primary key, and when we change a row, we send additional data, which is the primary key as well of the changed row. So we have a separate database, which is, I have not shown that because that will be much internal detail, but we check for the ID of the particular primary key. If two transactions are executing, and if I am the first one to execute, I see that the primary key, the identifier is X, and the state was Y. So my state, I have seen the latest update, so I can go ahead and commit and change the state to Y plus 1. Now the second transaction that comes in, since they were executed simultaneously, it also executed on the same state Y when it started execution. But when it comes to the certification stage, it sees that the state has changed to Y plus 1. So ideally, what I started with, the identifier with which I started, the state of that particular row has changed because the primary key is still the same, so the mapping changes. I have not seen the latest data, and therefore I cannot commit because I am working on the stale one. So in that is how certification works, and this will be rolled back. And this database over which the data is certified is consistent on all the members in the group, because it is based on the order in which the transactions are applied on different members. So it is always the same on all the members of the group. So certification result is same on all the members. It will never be different on different members. Any more questions? Okay. Thank you.